All right, today is going to be for my elementary school learners. All right, anyone that's trying to get some like super fundamentals. I'm gonna focus on some addition and subtraction techniques. The subtraction technique is geared towards a specific type of problem that has to deal with regrouping. So I want to talk about that in particular, and then I'll probably do more videos over just all types of subtractions. All right, so addition, subtraction with an emphasis on the regrouping. Before I get into the way that I'm going to explain it, I want to talk about the way that it's taught traditionally. This is the way that I've been taught. It's probably the way that you've been taught. It's been taught like this for years. It even goes back to the way my mother and even grandmother has been taught. So like if we have a 579 and we're told to add 465, the traditional method says we start right here. Now we add the 9 and the 5 and we get a 14, and then we put the 4 here and we carry the 1, right? So now by carrying the 1, instead of adding 2 numbers, now I have 3 numbers to go with, right? So now I have 1 plus 7, that's 8, plus 6 is 14. And once again, we put the 4 here and carry the 1, right? Now we have a 5 plus 4, which is 9, and then we have that 1. Now we say, and our answer is 1,044. So the issue I have with that method is, now because I'm a math student, or I was inclined to really kind of get the subject, the reason why I got good at this addition back then is because I was good at following directions. That was the only reason why I got it. That's what I was told to do, so I did it. I think I remember asking why, and then that response from my teacher was, "You just do it." What kind of explanation is that? You just do it. Like that's not an explanation for someone who's really trying to get what's going on. So number one, there's an issue with that. If you have some type of step or technique, it doesn't matter who asks you the question. You're supposed to be able to tell them why. That's very important. So let's get into another way of looking at this, because that way is a traditional, we call that algorithm based. It's based on like rules, and the rules are just the rules. There's really no reason behind it. And if there is, the people that are teaching you really don't know the reason either. So this is the wrong way to teach it. It's untruthful, and we call that anti-math. Now, I got this saying from a professor that I followed online. I found out about some years ago by the name of Professor B. All right. So Professor B has a philosophy behind teaching fundamentals in mathematics, and it has to be based on the truth. All right. Math is based on the truth, which will be the right way. All right. So if this is an untruth, we call that the wrong way, and we call that anti-math. So it's not mathematics. It's the opposite of mathematics. All right, so let's talk about some truthful ways of doing this. All right, so let's break down every digit that we're looking at. See, we're looking at this, and if I point to that number and I ask you what am I pointing at, most people will say I'm pointing at a 5. All right? Most people will say I'm pointing at a 5. That is what we mean by truth versus untruth, right? Because that is not a 5, because it sits over here. That's a 500. So this is based on understanding your place value. That's the hundreds place. Now, if I point at this number, that's not a 7. That's a 70, like 70. So that's not a 7 because it sits in the tens place. So I have 7 tens, right? That means I have 70. So that's my tens place. So that's not a 7, that's a 70. Now if I point at that, that is a 9 because that 9 sits in the ones place. So everything that we're about to talk about with this addition is based on place value. It's based on place value. All right, so remember how we did this one? most people, we start right here and then we work our way that way. That in itself is something wrong about that, because we don't even read from right to left. So why should we be doing addition from right to left? We should be going from left to right just like we do any other thing, right? So if I'm looking at this, what I'm going to look at, I'm going to start here in the hundreds place, and I'm going to look at the 5 and the 4 and say, okay, if I add that up, that's 900. Then I come in to the middle, then I look at that 70 and that 60, because 70 plus 60 is 130. So I write 130. Then I come over here to the end. 9 plus 5 is 14. And what I'm looking at is something extremely simple down the line. I'm looking at a 4, and a 10. There we go. 1044. The same thing that I got there. This makes way more sense. Now, what's going to happen is this part gets longer right here in the middle, but it's a mental process. And what's going to happen over time is your learners or your students, they will start being able to add larger numbers mentally. They're going to do it enough times on paper that by the time they get to like middle school, high school, they'll be able to do this type of thing mentally extremely quickly. All right, so when it comes to addition, when you're adding, you add from left to right based on place value. All right. So practice doing those with all sorts of numbers. Just practice doing those additions from left to right based on place value. And you'll start to see, okay, that makes way more sense than why am I carrying a 1 over to the middle and regrouping and doing all this other stuff. When you add based on place value, you'll notice you'll start blocking those numbers out, and then you really won't have to regroup like that. So just keep playing around with those and you'll get stronger in some fundamentals in addition. All right, let's look at some lower subtraction facts. 2 digits minus a 1 digit, that type of thing. So I have a 14 minus 6. So 14 minus 6 is 8. Now, there's different ways that we may learn how to do it. Some learn how to count on their fingers. They start with the number 6, and then they'll say 7, 8, 9, 10, 11, 12 until they hit 14. And when they look at their fingers, they'll notice they'll have 8 fingers up, right? So that's one of the ways that we talk about the subtraction. That's not a good way of, well, it kind of works, but I think there's a better way of explaining this, all right? So to get this same 8 and for it to make sense, we got to look at this as, just imagine you have money in your right pocket and you have money in your left pocket. So just imagine you have money in your left pocket and your right pocket. In your left pocket, you have a $10 bill, right? But in your right pocket, you have $4. Now, you go to the store and you got to purchase a sandwich for $6, right? Which pocket are you going to take your money out of, right? You're going to take your money out of this pocket and you're going to spend 6 from here. So from this pocket, you will spend 6. And then you'll get change of 4. And guess what happens? That $4 change stays in your left pocket. You have $4 already in your right pocket. So guess what you have total? You have $8 total. You get what I'm saying? This is a money method, right? So 14, we look at that as 10 and 4, and you're only spending from the 10, not from the 4. That's why we don't have to use regrouping when we think of it this way. And you still get the number 8, and I think that makes complete sense. All right, so now that we kind of understand that based in terms of the money in the pocket, 10 in the left, 4 in the right, this is how we actually work it. Because of that 10, we're spending from that 10. That leaves me with $4 right there. Get what I'm saying? That's 10 minus the 6, that's 4. I add that up, I get 8. That's how we do that subtraction. All right, so just keep kind of playing around with those because the more you play around with those, once again, as your students get older, as you get older, as you progress, you keep practicing, you work with numbers, addition and subtraction, you'll get extremely swift up here because your mental process will be on point. It won't be based off what you memorized and maybe forgot, or what you memorized or you thought of the rule and applied it the wrong way. All of that is eliminated because that's the absolute truth. You've done it plenty of times when you had money in your pocket. You didn't take out the whole amount. You pulled the bills that you needed to get your change, and then you add it right back to your pocket. It's the same thing that we do when we go to the store every single day if you're using cash. All right, so here's another subtraction problem. I'm going over this one because my niece had a problem similar to this one, and she was struggling with the whole carrying regrouping thing. And the reason why, because it's being taught the traditional way, the wrong way, untruthful, anti-math. All right. So let's look at this. This is the way that she was told this goes. Remember, we start from right to left, the traditional way, which is already backwards. We try to take away from zero, but you can't take away from zero. So we got to come over here and borrow. Right. You remember that? Borrow. I need to borrow. But there's nothing here to borrow. So we have to go all the way over here and borrow again. Right. So we have to turn this into a 5, right? Which makes this a 10. And folks is like, why does that become a 10? I don't know. You just do it. And then once again, untruthful, wrong way of doing it, anti-math, because they're trying to memorize something that doesn't make sense. Now we got a 10 here, but now we got to borrow from that, turn that into a 9, bam, turn that into a 10. You get what I'm saying? And then all of a sudden we can go back into doing backwards mathematics because we starting from the right and working our way to the left. So now we can do some subtraction here, and then we get a 4. Then we do some subtraction there. We get a 7. Then we do some subtraction there, and we get a 4. So we get a 474. So that's what happens when you have 600 minus 126. You get 474 as taught the traditional way. This is how it's taught the traditional way. And we wonder why our students, when they're older, they can't do subtraction in their head. Because who's going to keep up with all of this in their head? There's an extremely better way of doing that makes way more sense. It takes way less time and it takes way less brain power. So I'm going to talk about that one real quick. I think if that doesn't make sense to you, I really don't know what else to say, right? So that's how confident I am in what I'm about to show you. So the way that they have been teaching this with the regrouping from right to left, carrying it down, writing your numbers out backwards, getting your numbers correct at the end, we got to eliminate all that. So I'm going to take this same problem. I'm going to show you the way that it should be done. And then hopefully we can get back on track when we start doing some higher order subtractions. Okay, are we ready? I have 600 minus 126. This is all you have to do. All you do is take away 1 from both numbers. That's it. 600 will bump down to 599. That's 1 less than 600. And then 126, we're going to take that down to 125. And look what I got. 474. Why do all of that regrouping, which is the traditional way, which is the wrong, untruth, anti-math, right? When all I had to do was make each number 1 number smaller and get the same answer. This is the way that we do this. This doesn't require regrouping, and that makes way more sense. All right, so that's all I really had to go over today with your fundamentals, some addition and subtraction requiring regrouping. I do not teach at those levels. I teach upper level mathematics in high school, AP calculus, pre-calculus, algebra 2. I know the geometry, I know the algebra, I know all of that. I don't do stats right now, but I'll probably learn that at some other point. But my point is, the way that you've been taught this is the same way that I've been taught it. So I've actually been spending a lot of time unlearning those techniques and getting back to some techniques that make sense. So as I kind of tighten up on those and learn those techniques over again, I'll be making more videos as I get those mastered. So I hope those two in particular help, especially for my elementary and middle school students, because these fundamentals are extremely important for someone like me. Believe it or not, those 4 operations, addition, subtraction, multiplication, and division, if you can master your basics, you can be extremely good even when you get to the AP calculus level. So just make sure you're working on your fundamentals and just have faith. The fundamentals will get you through it. All right. If you're on YouTube, you can search BJ Jeffries. That is the correct spelling. It'll populate a list similar to this one. And this is the picture you're looking for. You're looking for this picture, and this is the channel you want to subscribe to. I place videos up every day I come to work.